Hi there, my name is Krishnan, Senior Consultant at Adobe. I'm here to talk about Amazon Web Services and Adobe Experience Manager. Adobe Experience Manager provides a rich set of tools for the marketing user which helps them to create and manage sites, assets, mobile applications, complex forms, and social communities. Let's quickly look into the internal architecture of Adobe Experience Manager. Henceforth, I'll refer to Adobe Experience Manager as AEM. AEM runs on the Java platform. It uses the industry standard OSGI container to manage the entire stack. At the core of it is the microkernel, which is where all the content is stored. We have two options here. We can use the tar microkernel or the Mongo microkernel. The tar microkernel is a self-appending tar file which stores all the data on the disk. Mongo microkernel is the one which stores all the data on MongoDB servers. Apart from that, we can also leverage the Amazon Web Services features such as S3 to store all the binary content. The layer above the microkernel is the oak layer. The oak layer is a layer which exposes the underlying content repository as mutable and immutable objects. It also represents them in a hierarchical manner. Everything else apart from that is plugins. The list of plugins that Oak supports out of the box are search, indexing, authentication, authorization, lock management, data validation, etc. The layer above the Oak and the plugin layer is the Sling layer, which exposes the underlying layers with a HTTP wrapper around it. It also works based on RESTful principles. Above that is the Adobe Experience Manager UI layer, which provides a rich set of tools for the content authors to interact with the system. When we compare with the traditional web application architecture, the microkernel maps to the data tier, the Oak and plugin layers along with the Sling map to the middle tier, and your AEM UI is the presentation tier. In this slide, we'll talk about the different infrastructure building blocks and also how it works. At the bottom, we have the marketing users, the author server, the publish server, the dispatcher servers, the Elastic Load Balancer, and the internet users who are also our customers. The author server is a server which is where the content authors create their content. It provides a rich set of specific tools to support content authoring, and also allows the marketing users to configure the sites with analytics, campaigns, targeting, and other tools available in the marketing cloud. It is a stateful server and works based on RESTful principles. Publish server is a server which hosts ready to consume content, and it is a server which runs on the same software as the author server but in a scaled down manner. It is a stateless server and runs based on RESTful principles as well. The next layer is the dispatcher servers. Dispatcher servers is basically a custom module which runs on Apache or IIS servers. It is primarily used for caching of content. It provides load balancing and intelligent routing features and usually placed in front of the author and the publish servers. Above it is the Elastic Load Balancer, which distributes the traffic from the internet to one of the available dispatchers to serve content. Okay, let's see how it works. The marketing users access the author server to create all their content. When the content is ready, they activate the content to the publish servers. The publish servers receive the content, and once they save on their disk, they basically trigger further events which flush the dispatchers to invalidate their cache. So the author to the publish and publish to dispatcher, this connectivity happens via replication agents, and replication agents run on HTTP. As we know, the Elastic Load Balancers are routing traffic to the dispatchers. So when a request comes in from an internet user, it hits the Elastic Load Balancer, goes via the dispatchers, and hits the publish servers. The publish servers render the content, and once the content is rendered on the publish servers, the request is routed back to the user via the dispatchers. At that point, the dispatcher caches the content on it and also sends out the response to the requesting user. Subsequent requests for the same content is served from the dispatcher server. From this point onwards, we'll look at the different architectures and their use cases. And the first one is the development setup. Development setup is something that you use in every project. This is where the developers collaborate during their project development. We can run all the servers on Amazon Web Services, the fundamental ones being author, publisher, and the dispatcher service, all running on AZ1. The advantages, let's look at the advantages and disadvantages of this setup. It's easy to set up because it's very fundamental and basic. Once you script it, it can be built in a matter of a few minutes. It's good for running your proof of concepts, even doing your learning, and also for practicing purposes. The disadvantages of this setup are the authors are not fault tolerant, the published service cannot scale, and hence not suitable for production. The next architecture we want to talk about today is the highly available architecture. The use case for this one is, this is best suited for customers who have a predominantly static site and also have minimum number of activations in general. Most of the banking sites and other financial institutions run on this setup, so it's quite common. In this architecture, we basically have the author server, the primary instance running in AZ1, and the author cold instance running in AZ2. The author server, the primary instance, and the cold instance basically sync in near real time using cold standby or rsync. We also have the published servers distributed across both the availability zones. We have the published servers and the published gold servers on both the availability zones. The published gold servers are primarily there to create copies when there is a need to scale. We also have the auto scaling group enabled using CloudWatch. CloudWatch basically monitors the CPU or the network traffic on the dispatcher service. Once it hits a certain threshold, it basically triggers scripts that creates publish and dispatcher pairs on the fly. And those scripts can also be used to scale down the service when the peak has passed. Let's look at the advantages and the disadvantages in this setup. It is a highly scalable architecture, especially on the runtime. Since you're running TarMK, the performance is great and the authors are fault tolerant. The disadvantage is that the authors cannot scale at any given point in time. You just have to run only one author server. And the author servers, the failover on the author servers is manual, so there is downtime. And at any given point in time, there are a few servers which are idle. The next one we're going to talk about today is the digital assets heavy architecture. This architecture is best suited for customers who have a large repository, usually in the order of terabytes. Best suited for companies which manage a lot of stock images and things like that. In this architecture, we basically have the author server, the primary instance running on AZ1, and the author cold running on AZ2, and they are both synced using cold standby or rsync. And the author servers also store their binary content in S3 buckets. We also have the published servers available on the availability zones AZ1 and AZ2, and they also connect to the same S3 bucket as the author servers. One of the main advantages of the S3 bucket is the fact that it gives us storage scalability. And also, when you activate content from the author service to the published service, it's not the binary asset itself is not replicated from the author to the published service. It only replicates the metadata from the author to the published service, and hence the author and the published service point to the same asset on the S3 bucket, which kind of brings down your storage costs, and also you can leverage on the durability and scalability of S3 in this case. And this feature is referred to as binary-less replication. Apart from that, the other advantages that we can use are with auto scaling group in place and with CloudWatch. You can basically scale the published servers on demand by making copies of the published gold server. The advantages and disadvantages of this architecture are now we can support a large digital asset repository, and we can also have failovers in multiple regions because S3 spans across multiple regions, but it's very efficient on the same region. But yeah, in case of a disaster, you can basically run it from a different region as well. It supports binary-less replication, hence bringing down the costs. The disadvantage is that at any given point you can basically run with one author server, and there are few servers which are idle. This architecture is best suited for customers who have global enterprises or news and media companies who have reporters spread across different regions in the globe and need the servers available 24/7 without any downtime. In this architecture, we basically have the author servers and publish servers spread across multiple regions. As shown in the diagram, we have the author servers in Sydney and also in the Singapore region. Each author server, in order to reduce the latency, we have MongoDB servers running in the same region, and also to make elections quicker and without any conflicts, we also have the MongoDB arbiter available in the Sydney region. So in case if a server goes down on the Singapore region or the Sydney region, the MongoDB servers can manage the replica sets more effectively and be available to the author servers as soon as possible, right? And we also have the publish servers spread across multiple regions in this case, and the dispatcher servers and elastic load balancer and the users. On the runtime side, we have our auto scaling group, which uses CloudWatch, similar to the previous architectures, where it monitors the dispatches for CPU and network, and based on latency on any of these statistics on a set threshold, it can basically replicate. It can basically create pairs of publish and dispatches, taking copies from the publish gold server, and can also scale down when the peak is gone. The advantages and disadvantages of this setup are on the advantages side. So we can basically span across different geographies and provide efficient content authoring experience. And because of the underlying MongoDB architecture, the architecture is more resilient and it is scalable. And there is also no downtime on the authoring service, because if one region goes down, the other is still serving all your requests. And since we are using tar microkernel on the publish side, we still get the benefits and performance efficiencies of the tar microkernel. The disadvantages are that now that we have introduced a new component, the MongoDB, you require additional skill set to manage. The performance is not as great as a tar microkernel on the authoring side, and there we have more servers to monitor and manage. The last architecture for today is the user-generated content architecture. In this architecture is best suited for customers who run blog comments, ratings, forums, and also want to provide Facebook-like features on their website. This architecture is quite different to the previous architectures because of the fact that on all the previous architectures, the author was creating the content and the publish servers basically had those content on the publish servers and the users consumed it. What's different about this architecture is that the end users in this case will be posting content to our publish servers. Okay, let's look into how this architecture is laid out. We have the author server in availability zone 1 and the author cold server in the availability zone 2, and we use the cold standby feature to keep them in sync or use rsync. Content from the author is basically replicated from the author server to the publish servers. The publish servers are powered by MongoDB in this case. So we have a MongoDB server in both the availability zones and also supporting it with the arbiter, which convenes elections. In order to scale the servers on demand, we basically have the auto scaling group powered by CloudWatch. Whenever there is a need to spin up more publish servers, all that we have to do is create a publish server and connect it to a MongoDB server, and that's one of the major differences compared to the previous architectures, because in the previous architectures we had the publish gold server meant for that. In this case we don't have the publish gold server. All that we need to do is spin up a publish server and just connect it to the MongoDB servers. The advantages and disadvantages of this setup are the advantages side. We basically can manage UGC more effectively with this architecture. We also have horizontal scaling on the runtime with MongoDB and the publish servers, and moderation can be done specifically on the publish servers now. The disadvantages is that you need MongoDB skill set to manage the service, and since you're not running microkernel on your runtime, there is a slight lag in performance, and you also need to monitor and manage more service now. Thank you.